So, good afternoon, everyone, and welcome to EduMath Up. So, today we'll be treating this topic, theory of logarithms. This is one of the topics in JAMB syllabus. So, if you're preparing for JAMB examination, it's very important for you to know about this topic. If you're preparing for WAEC, maybe you're preparing for NECO, very important for you to know about this topic, okay? And if you want to get the general knowledge about logarithms, you can watch this video too. Now, let's get right into the topic. Now, before you start logarithms, it's important for you to know about what is called a base and what is called a power. Now, let me just give you a literal example. You have a raised to the power 5. When you have a raised to the power 5 like this, the number at the bottom part here is called the base. You can see it's at the lower part. That's why it's called the base. Now, the one at the top is called the power. Okay, so you have base and power. If you have 2 raised to the power 3, 2 raised to the power 3, this 2 here is the base, then 3 is the power. So this power, you can also call it index. So that's about basis and power. So it's important for you to know how to find or how to identify the base and how to identify the power. Now let's define logarithms. Okay, so you can have an idea. So logarithm is defined as the logarithm of a number to a base is defined as the number to which the base must be raised to give that number. Now you don't have to bother yourself about the definition, but you need to know how to identify the base, the power, and the original number. Now take this example. You have 2 raised to the power 3 is equals to 8. That's because 2 times 2 times 2 will give you 8. So you have 2 in 3 places. That's 2 raised to the power 3, which is giving us 8. Okay, now in terms of logarithm, you define logarithm as the number to which the base must be raised. Now let's look for the base here. The base here is 2. 2 is the base. This 3 is the power. So we have known the base and we have known the power. Now this 8 is the number that we are trying to get. Okay. Now what will you raise 2 to get 8? Because logarithm is the number to which the base must be raised. What will you raise the base to get 8? That's what logarithm is about. What will you raise 2 to get 8? That's when you write 2, which number will be here for you to get 8? The number that will be here is what is called the logarithm. Okay, so you have to raise, to get 8, you have to raise 2 to the power of 3 to get 8. That means that the logarithm of 8 to base 2 is 3. Let's take another example. Now let's look at 25, for example. Now 25, we have 5 raised to the power 2 is equals to 25. So 5 is base, 2 is the power. Now 25 is the number. Okay, now ask yourself, what will you raise 5 to? When you have 5, what will you raise? Which number will be here? What will you write in this box for you to get 25? So you see that what should be in that box should be 2, because 5 times 5 is 2. Sorry, 5 times 5 is 25. So 2 should be here. So in logarithm form, this should be log 25. This one here, the base will be at the bottom here. Then the logarithm, the 2, the power or the index will be outside. So that's about the definition of logarithm. The number to which the base, this is the base. What will you raise this base to get 25? So that answer will be 2. And it goes on and on like that. Okay. Now you need to know how to convert from what is called the index form to the log form. Okay. So now let's move to the next part. So for this next part, we are looking at how to convert from index to log form. So pretty simple. I'm very sure you get the hang of it after this topic. So let's look at it together. So now the index form is the expression, okay, without the log there, without the logarithm there. So you have something like um, index form, and this is log form. So in tabular form, to make it easy for you, you see you have 3 raised to the power 2 is equals to 9. That's 3 times 3 will give you 9. Okay. Now in log form, for you to write this in log form, it's very simple. You just have to write your log first. Okay. Now this is the base. Identify the base. This is the base. This is the base. This base will be at the bottom of the G here. Okay. Then write your equals to. This 2 is the power. This power will be outside here. Then the 9 will be here. So you're converted from index to log form. Let's look at another example. 5 raised to the power 3 is equals to 125. You write your log. Now let's look at the base here. The base here is 5. 5, that's the base. 3 is the power. Now this b, which is the base, which is 5, will be here. Then you put in your equal sign. This is the power, 3. The power will be outside here. Then 125 will be right here. Okay. Now you can also reverse this process. Okay, you can reverse this process. You can move from the log form to the index form. This is how you do it. Very, very simple. Let's take an expression in log form. Let's look at log 10. Then let's put 1000 here. Let's put 3 here. Now to convert this to the index form, don't forget, in the index form there will be no log, there will be no log in the index form. So the first thing to do is to use the base to raise the power. Don't forget, raise, not multiply. If you do 10 raised to the power 3, that will give you 1, that's 10, that's 10. This 3 will be at the top here. Then write your equals to, then put this 1000 outside here. 10 raised to the power 3 is 1000. That's 10 times 10 times 10 will give you 1000. Okay. Now let's take one more example. For the next example, let's take log to index form. Let's look at another one. You have log 4. Then let's put 16 here equals to 2. So it's the same process. This 4 will raise this 2. Please, not 4 times 2. 4 raised to the power 2. So that should be here. Equals to, then 16 will be right here. So that's about converting from index to log form. Please, if you are liking what you are seeing right now, please like and subscribe to the channel for more videos like this. Okay, it keeps us going. And let's move on to the next aspect of the video. Okay, now, so move on to the next part, which is evaluation of logarithms. So we're looking at how to evaluate logarithms. Okay, so for you to know how to evaluate logarithm, you need to remember some laws of indices. Okay, you need to remember some laws of indices. Don't forget, the laws of indices are very similar to the laws of logarithms. Okay, so let's do a recap. For laws of indices, so I've explained the laws. So you have a to the power 0, a to the power 0 is 1. That's any number is to the power 0 will give you 1. Okay, I'm just trying to do a recap. Now you have another law, a to the power x times a to the power y is equals to a to the power x plus y. That's when you're multiplying indices, when they have the same base, a, you should add the powers. Okay, that operation is similar in logarithms, as we'll be seeing later. Then You have another one, which is the division law. So you have a to the power x divided by a to the power y. Now since you have division, so what you do is minus a to the power x minus y. You just subtract the powers. Okay. There is another one, root of a. Anytime you see root of a number, it's the same thing as writing that same number, then raising it to the power half. So raise it to the power half. For example, 64 raised to the power half. It means the square root of 64. That's the meaning, which will give you 8, because 8 times 8 is 64. Okay. Alright, now for another law, I'm just trying to pick the ones that are important to us. Now let's take another law. You have negative index law. When you have a number that is raised to a negative number, like a raised to the power minus n, what you have is 1. You have to remove this minus first. So you have 1. Once you introduce 1, the minus will disappear. Then over, then you write this same thing, but don't include the minus. A raised to the power n. Okay. So these are the basic laws of logarithms. Okay. There are still a couple of them, but let's just focus on these ones for now. Let me add one more. A raised to the power m over n give you n. This n at the bottom part will form the root sign. You have a right here, then m will be outside here. So the one at the bottom part, the denominator will form the root sign, then the numerator will become the power. Now these are the basics of the laws of logarithm. Now let's go into how to evaluate logarithms. Now we'll be using some of these laws. So let's look at some examples on how to evaluate logarithms now. So let's look at some examples. So the first example here, you have to evaluate log 216. Okay. You have to evaluate this. Now to pronounce this, you say log of 16 to base 2. Okay, log 16 to base 2. Okay, log 16 to base 2. Now that's how you pronounce it. Now I want to evaluate this thing. To evaluate it means as this particular logarithm expression is equals to a particular value. So that value is unknown. So pick a letter to represent that value. So you can say log 216 is equals to x. Now after picking that, the next step you have to convert to index form. Okay, please convert to index form. You cannot solve this thing like this. You have to convert to index form. So we move to the index form, which is what I've treated earlier. So convert to index form. So this 2 will raise this x up, not 2 times x, not 2 times x like this. Okay, not 2 times x, but 2 raised to the power x. So we have 2, the x will be at the top, then this 16 will be out here. So you have what is called an integral equation. This is an integral equation, or an equation based on indices. So the next step will be to express 16 as the power of 2. So break 16 down. You have to express this right hand side to look like the left hand side. So you have 2 to the power x, then 16 is 2 to the power 4. That's because 2 times 2 times 2 times 2 will give you 16. So 16 has been broken down to 2 to the power 4. Now the bases are the same. You can see the bases, they are the same. So since they are the same, you just ignore them or you cut them out. So you have 2 to the power x equals to 2 to the power 4. Cut these two out. Then your final answer will be x equals to 4. It just equates the bases. Okay, it equates the powers rather. So x is equals to 4. Okay, So since the bases are the same, it equates the powers. Okay, it can also occur in the reverse form. At times you might have the powers the same. Take for example, you have x raised to the power 2 is equals to 4 raised to the power 2. Here the powers are the same, so it just equates the bases. So x is equals to 4. This is just an example. Okay, now let's take one more example on how to evaluate logarithms. Okay, now we have another example here. We have log 32 to the base 4 is equals to, you have to evaluate, this. So now you have to evaluate this logarithm expression. So the first thing to do, you have to equate it to a number, or a letter rather. So let's do that. For the solution, we say log 32 is equals to, let's say, y. So the next thing, convert to index form. That's the next step, because you cannot solve it like this. You have to convert it to index form. So we convert to index form. Now this 4 will raise this y up. Please, not 4 times y, but 4 raised to the power y. So you have 4 raised to the power y equals to 32. Now the next step is to break each side, the left hand side and the right hand side, break them down to look or to have the same base. Okay, now that's pretty simple. If you check what you have on your screen, you see that 2 is a factor of those numbers there. So 4 is 2 raised to the power 2. Okay, so let's break that down. So this is 2 raised to the power 2, but there's y at the top, so that will give you 2y. 4 itself is 2 raised to the power 2, but because of this y, you put it beside it. 32 is 2 raised to the power 5. That is 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. Okay, so 32 is 2 to the power 5. Now the bases are the same. You can see the bases, they are the same. They are the same. So what will you do next? You just equate the powers. Okay, so you equate the powers. So equate the powers. If you do that, you have 2y. 2y is 2y is equals to 5. But you're looking for the value of y. Don't forget. So you divide both sides by 2. So divide both sides by 2. This will be over 2. Then your y will be 5 over 2. So this is how you evaluate logarithms. Okay, please like and subscribe to the channel to keep us going for more videos like this. Now this is how to evaluate logarithms, and we've already done 2 examples. Okay, now let's take the last example, just the last example, just one more example. Let's go. Now let's take one more example. Now if you do that one more example, I want to make it a bit complex. Let's make it a bit complex. You have to go for difficult things. If you want to become the best, okay, you need to go for something that is a bit difficult, so something that will challenge you. In life, if you are not challenged, you might not become the best. You need to be challenged to know that you are the best. So let's make it a bit complex. So you have log 4 root 2. So you have to evaluate this. This is actually a jam question. So the first thing, equals it to a letter. Okay, let it be equal to a letter or a variable. So this is what you have at the end of the day. I'm using x. Okay, I'm using x. So the next step is to convert to index form. So this 2 will raise this x. So you have 2 to the power x. Then you have 4 root 2. Then you have 2 to the power x. 4 is 2 to the power 2. Don't forget what I told you. Then you have root 2. Root 2 is the same thing as 2 raised to the power half. Root 2 is the same thing as 2 raised to the power 1 over 2. Okay, so using that idea, root 2 here will be times 2 raised to the power half. Then we apply the law of indices. because we have the same base here. The bases are the same. You can see the bases, they are the same. Just add the powers. So the left hand side is 2 to the power x is equals to, now we are adding the bases. So we take the base 2, then we add the top 2 plus half. So 2 plus half will give you 5 over 2. Okay, 2 2 plus 1 over 2. So if you do that addition, 1 and 2 is 2, 2 times 2, 4, plus this one will give you 1, so that will give you 5 over 2. Okay, so 2 plus half is 5 over 2. Then the next step is the bases are the same, just equate the powers. Okay, so these two cancel out, so x is equals to 5 over 2. Okay, so that's about evolution of logarithms. If you're still on the channel, please like and subscribe for more videos like this. Now let's move on to the next aspect.